Okay, so here, just going through these proofs, it starts out pretty easily, just using what we learned yesterday and in chapter 2. So first of all, given is angle 1 is congruent to angle 2. You just write that in your first statement, and that is your given. And then also, before you even look at the problem, our proof statement is L is parallel to M, so you can write that in there too. Okay, so it's saying that 1 is congruent to 2. We can see that those are corresponding angles. If corresponding angles are equal, that means that this line is parallel to this line. So the reason why L is parallel to M is the converse of corresponding angles postulate. Converse of corresponding angles postulate. Now, these on standardized testing will always be multiple choice or drag and drop of some manner, so you don't have to be able to write that from scratch. It's just recognizing that in answer choices. So I'm sure you would. Wonderful. Watch later. Okay. I'm sure you'd recognize the corresponding angles, and then it's oh, well, how do I know to put converse, or is it theorem or postulate? It doesn't matter. As long as you can recognize corresponding angles and recognize that in the answer box, that's what you should be at. Next, again, we have a given is angle 1 is congruent to angle 3, and that is given. We're trying to prove, again, that L is parallel to M. And so I look over here at the chart. 1 and 3 are alternate interior angles, and when alternate interior angles are equal, like it says, that means line L is parallel to M. So the reason would be the converse of alternate interior angles theorem. Okay, now it gets a little bit harder. Well, maybe you'll find it easy. But of course, they give us a given. Angle 1 and angle 3 are supplementary, so we just write given here. They already plugged in the proof statement. I'm also going to look at the chart to see what it's talking about. It's saying, okay, so 1 and 3 are supplementary. That means they add to 180. So the next statement, it says 1 and 2 form a linear pair. I'm looking at the chart over here. 1 and 2, they do form a linear pair. There are two angles that come together to form a straight line. That is just definition of a linear pair. And then for 3, it says 1 and 2 are what? Well, if 1 and 2 form a linear pair, then they are supplementary. And that is linear pair postulate. If two angles form a linear pair, then they are supplementary. And then from here it says, okay, 2 is equal to 3. And I recognize those as corresponding angles, but I can't say they're corresponding because I don't know that A and B are parallel yet. So the reason why 2 is equal to 3 is actually, and you might not remember this, but congruent supplement theorem. And I'll explain what that is again. Congruent supplement theorem. It came up once briefly, but our theorem. Okay, what congruent supplement theorem was that if you have two angles that are supplementary and then that same angle, so angle 1 is also supplementary to angle 2, then 2 and 3 are actually equal. So if 1 is supplementary to 3 and 1 is also supplementary to 2, then 2 and 3 are equal. That was the congruent supplement theorem. And then, last but not least, we're going from, okay, so 2 and 3 are equal. That means that line A and B are parallel. So, and that would be the converse of corresponding angles theorem. Or wait, not theorem, it's a postulate. Same thing, but yeah, postulate. Okay, and next. So in this case, it doesn't give us, well, there's actually two givens here. L is parallel to M and angle 6 is congruent to 11. So I'm going to write this L is parallel to M, that's given. And then it says angle 6 is congruent to angle 11, that is also given. And I'm also going to plug in my proof statement, T is parallel to S. Okay, now I'm looking at what I have. They're saying, okay, L is parallel to M, that's given. They're saying 6 is equal to 11. So 6 and 11 are congruent. Then it says that 6 is congruent to 3. Okay, so 6 and 3 are alternate interior angles, so yes, they're congruent because they're alternate interior angles. And then they're saying, okay, if 6 is equal to 11 and 6 is equal to 3, then 3 and 11 must be equal. That is transitive property. And then looking at 3 and 11 are right here. So this angle and this angle, they are corresponding angles. So if those two angles are equal, that means that T is parallel to S. So converse of corresponding angles, postulate. Okay, so that's it for proof review. I'm going to have you practice